How many astronauts are here? How many astronauts are in the audience? Okay, how many about aerospace engineers? Any satellite engineers in the audience? Yes, I suspected that would be the case. So I want to tell you a story about designing satellites, because that's what my organization does. Whenever you build a satellite that orbits the Earth, in addition to whatever that satellite has to do, like provide communications or observe a certain part of the planet, there's another thing that the satellites have to do. Those satellites also have to measure, there's special instruments on the satellite that have to measure all of the forces that are acting on the satellite at least as fast as those forces are acting on the satellite. So the reason that you have to do that is because if you only measure, say, once every half an hour how the satellite is doing, it could start to spin out of orbit. And by the time it's tumbling, you don't have the information that tells you whether or not the instrument is secure, and you can't recover the satellite. So it's so critically important when you're designing a satellite that you measure the forces acting on it as fast as those forces are occurring. Now, the reason I tell you that story is to tell you another story, which is that we live on a satellite. And in fact, everyone in this room is an astronaut, because we're all on this satellite. It just happens to be going around the sun instead of going around the Earth. And you may have heard that life on Earth and our ecosystems and our climate are in a precarious state, more precarious than they've been in the entire history of human civilization. The satellite that we live on is beginning to tumble out of orbit. And if we want to recover that satellite and keep it in good and healthy condition, we have to measure the forces of change acting on it at the same speed that those forces are unfolding, in the same way that we have to measure the forces that are operating on a normal satellite. So I'm going to see if my slides will work here. Okay, so this is the really important thing, right? I show you two satellites here. This is the one on the bottom is a satellite, the one on the top is a satellite. So 3 ideas I want you to start with. The first one is that before it's an action problem, sustainability is an information problem. Because if you don't know what the state of systems are, you can't act to engage with them. And if we measure too slowly, we will not, the rate of action is always limited by the rate of information. So it's critically important that we get information as quickly as possible. Now, the other 2 have to do uniquely with space, and that is that half of the most essential variables that we know about the climate that matter are only measurable from space. And indeed, satellites from Planet and others are responsible for measuring some 80 targets and indicators, and another 80 targets and 80 indicators under 14 of the 17 Sustainable Development Goals. So these are critically important tools for us to achieve the sustainability transition. So at Planet, the way that we do this is we've deployed a huge constellation of very small satellites. Normally, satellites are the size of school buses. Well, our satellites are about the size of a loaf of bread, packed with the same electronics, and we've put hundreds of them on orbit, in an orbit that spins from the North Pole to the South Pole, over the equator, down between the sun and the Earth. And as the Earth turns sideways underneath them, we line scan the planet every day in high resolution. So, how many people here have ever been to space? I asked before, I didn't see any hands go up. That means that every day for the last 7 years, everywhere you've ever been, we've been taking pictures of the Earth from space, of that place. Not at a resolution that can read your newspaper. We're not spying on you. This is a much coarser resolution, about 3 meters per pixel, but it allows us to see every tree, every road, every building, everywhere, every day. Now you can imagine how essentially important that is to this question of how do we drive sustainability. And here is probably the most important chart I'll show you in the whole talk I'm giving this morning, and this afternoon. The way we do all of this, the way we're going to solve all of these sustainability challenges, is by increasing the amount of information we use when applying ecologically intensive resources. So first we have to make the invisible visible. Then we can be much more precise in the way we use resources. So for instance, consider in agriculture, when a farmer needs to grow a crop, they have to apply inputs, seeds and water and fertilizer and insecticide. Using satellites, we can see precisely when and where to apply those scarce resources to increase agricultural productivity while decreasing the ecological intensivity of agriculture. And we've shown that sometimes the benefits can be measured in 100% improvements, a whole, like a growing twice the amount of food on the same amount of land. And why does that matter? The reason that matters is because one of the most essential things we have to do is protect our forests. And what is the principal driver of the desecration and deforestation of the elimination of our forests? It's the creation of new fields for agriculture to feed all of the new people who are arriving in this century. If we can make agriculture more efficient, we can depressurize our pressures on the forests. The forests can constrain and hold a lot of carbon, and that carbon is essential for us to meet our climate objectives, just as an example. Now, I want to show you a couple of ways what this looks like in practice. This is a sped up image of a couple of months, actually it's now a couple of weeks of satellite imagery deep in the Amazon. What you're looking at here is deforestation spreading across the landscape. That's all illegal deforestation. It's not allowed by law to occur. This deforestation, as you can see, it sort of looks like a virus spreading across the landscape. And if your eyes are like my eyes, you likely looked at the right-hand side of the screen first because it's so salient, it really pops. What you might not have noticed is what happens over here. Right after the deforestation occurs, you see these little spider webs that go in on the landscape? Those are the illegal roads that go in before the next round of deforestation occurs. They're the best indicator we have of what's about to happen. Now, here's where AI comes in. We've trained algorithms to find those illegal roads as they're going in and built a tool for the government of Brazil with our partners. So you can see here, this is 1 month. That road went in illegally in a month. And what you'll see here is a software tool that uses AI and all of that satellite imagery to identify every act of deforestation that's occurred in every one of these places every week and automatically generates a law enforcement action. It kicks off an interdiction action by the environmental police. And in fact, in the last year, our colleagues in the Environmental Police Unit of Brazil have deployed 3,800 agents over 120 operations. They've destroyed in the field more than 1,000 of these machines, the heavy equipment that is responsible for making the roads and taking the trees out. They've collected more than $2 billion US, and they credit this as one of the central mechanisms that has contributed to their ability to reduce the rates of deforestation in 1 year by 50%. That's what real-time satellite imaging and AI for the planet, that's what it really does. That's what it actually looks like. Now, it doesn't just tell us about what's not working, it also tells us about what's working. This is one of my favorite examples. This is the Xingu Indigenous Park in Brazil. This is what happens when you give indigenous land stewards tenure over the land. What you can see is deforestation spreading and then sort of resisting this. It's almost like meeting the wall of the cell wall, for instance, of this particular area. Now, we're doing a bunch of other things as well here, and I want to just give you 2 more examples to close out the session today. With our colleagues at Microsoft and an international NGO called the Nature Conservancy, we're applying AI and satellite imagery to track SDG number 7, which is the progress that we're making against global renewables. We're actually just about to launch a global open platform that uses the same tools that Google uses to tell you if an image is of a cat or a dog, to identify every utility-grade renewable energy resource on the planet and make it available for free to the world so we can actually see how we're doing. Now, renewables are an important piece of the story. They are not the whole story of the global energy mix, but it is essential if we want to fulfill the 300% increase in the adoption of renewables that we just agreed to here in Dubai in November, to actually be able to track our progress transparently, because transparency drives accountability. Now, the last examples I'll just give you quickly are, this is an equally important tool called the Allen Coral Atlas. The Allen Coral Atlas actually tells us how the health of all of the world's coral reefs using the same tools of AI and machine learning. And today, they've led to the creation of nearly 24 brand new marine protected areas, because when we can see where the biodiversity is, we can begin to protect it. The last one I'll just share with you is the latest thing we're working on, and this will be coming out over the course of the next year, working together with Microsoft and this very famous public health institute called the Institute for Health Metrics and Evaluation. They produce some of the canonical data that tells us about the global burden of disease. We're actually producing the highest resolution population maps for the world's populations everywhere on Earth. This happens to be the latest population map for Kenya. Now, the reason that's important is there are huge places in the world for which we have no information about where people live. What we're doing is we're able to zoom down just to a few meters. Every one of those pixels tells us how many people are living in that area, extracting this information from the satellite imagery. And where that gets important is where this goes next, to help us fulfill the 2030 agenda. At the bottom, once you understand where the people are, you can begin to layer on, where's the food insecurity risk? Or where's the threat of new diseases? Or where's the climate-induced migration risk? And as you layer these pieces on top of each other, we begin to understand how communities are fragile, vulnerable, where they are at risk, and where we can intervene not just after a disruption occurs, but before it occurs. So I just wanted to give you a little bit of a whirlwind tour. These are just some of the ways in which very practically, we have these conversations about AI and it feels a little abstract. We have these conversations about satellites. It's not in our day-to-day life. But practically, this is what it means to build the system that keeps the Earth or returns the Earth to balance, because it allows us to take the daily actions that allow us to keep ourselves and our larger community of life on Earth in balance. Why do birds flock together? Why do bees come together in swarms? Why do, you ever seen scuba divers? If you've gone scuba diving, you see fish swimming in big schools slowly. Okay, you would think this would be a very dumb idea, because if you're a little fish swimming with a lot of little fish, you look a lot like lunch to a large fish, okay? So why do animals do it? And the really big important thing here is not only do birds and bees and fish, but people do it too. Here we are swarming together, okay? So why do we do this? Well, the best hypothesis about why we do it is something called the many eyes hypothesis. When we are together in a group, your eyes are looking over there while my eyes are looking over there, and your eyes are looking over there, and your eyes are looking over there. And between all of us, we actually see a much broader array of threats and dangers than any of us could have seen on our own. And by putting all of those together, we achieve collective safety. So one of the most important things about all of the tools you just saw here, all of these assets, is that if we can get them into everybody's hands, not just the hands of the few, then we're enforcing collective safety in this area of this era of threats to sustainability. And with that, I will say thank you very much. Thanks.